Hello and welcome to day 9 of learning ML from chatgpt. Let's get started. I think yesterday the video cut off a bit early for some reason. OBS crashed. But today we won't be doing day 6's lesson. That I'll do for day 10, as we've already done this lesson and we just exchange it for the lesson we haven't done, which was this one. So today we're going to be doing deep learning architectures. Okay. Copy. Now please give me day 9's lesson. Please don't provide the PyTorch code this time. And the TensorFlow code. And also make sure to explain the code properly. Okay, because last time I wasn't explained it properly. So let's see. Deep neural networks. Hidden layers, nonlinearity. So what did I... Okay, let's see what we got in store for today's lesson. I think this is ChatGPT. I was using it quite a bit yesterday. ChatGPT built a weather investment app GUI. It was pretty fun. Okay, so deep neural networks, DNNs, a neural network with hidden multiple layers between input and output layers. These additional layers allow the network to model more complex patterns in the data. Hidden layers, layers between the input and output layers. They consist of neurons that perform intermediate computations. Non-linearity. Non-linear functions, activation functions like ReLU, allow the network to learn complex, non-linear relationships between the input and the output. Wait, so we've been doing... Oh, so this is just loads of them. Okay. Code example. Implementing a deep neural network in TensorFlow. Below is an example of building and training a deep neural network for binding classification using TensorFlow. So here, as we normally do, we have... it's not going to be greatest data, because after a while it's just going to be... Anyway. Is this... Yeah, this should be non-linear, because you have like a line here, and suddenly like... wait, no. Yeah, you have a line here on 0, then it suddenly just jumps up to 1. And yeah, that's non-linear. Like, you don't put a line through that. Like, it's got to have some sort of like exponent value. It's like, that's where a neural network comes in, because it's not just a linear line. You can get much better with the neural networks, like around the rest of it kind of thing. So here we're just getting, we're having 10 features this time, okay, and we're having 1,000 random ones, and then we're Y-train where we're summing up. So for every we fill these like 1,000 of 10 features with random values, then we're summing it all up, and if it sums up to a value greater than 5, we have 1, otherwise 0. So here we're actually creating a model. So a sequential model, as we always do for now. And so this is the first hidden layer, 16 neurons. Input shape 10, because we're having 10 features. And so we've got 16 neurons here, and we've also got the ReLU activation function. Then we've got another activation function here, ReLU again. So we're just using ReLU for the hidden layers, and the output layer we're using sigmoid. If you remember, that's the activation function where it outputs something in a range between 0 and 1. And like you can round it down or up, just round it to the nearest whole number in order to get the like prediction. So that's, yeah, it's basically the percentage it thinks. Like it can be 0.443752, but that will round down to 0. And yeah, like that's how you get the binary classification. So we see we have 3 hidden layers. This is the output layer, so it doesn't count. So 16, 32, and 16. I assume this helps as it goes to a bigger layer, like do a diagram here. So bigger layer to there and there, like, yeah. So I assume this is like a, not paradigm, but like industry standard, so to speak. So the more layers we have, the more time it will take for it to compute. However, the more accurate it will be, as we're introducing more non-linearity, so the model can learn on the dataset. Also, we're not using any of the L1 or L2 regularization here. Don't know why, but yeah, because in the chatgpt curriculum, we're not supposed to have learnt that yet, but we have learnt it. Where is it gone? I'll find it later. Okay, so then we're using Adam Optimizer, loss, bounding cross entropy, and metrics accuracy. So now we're going to do history model.fit, X train, Y train, 50 epochs. This is used to have 100 epochs, I'm pretty sure. Before, now we've halved it. Well, we got the 2 extra hidden layers, which kind of makes up for the less epochs. And we're also, before, we haven't been adding the validation split, so I'm curious as to what this is. Validation split. Most of validation split. Wait, no. Validate. 0.2. Oh, okay. I see. So we're of this training data set, we're saving 20% for validation. So this is how we can get the accuracy. Loss, val loss, accuracy, and val accuracy. So that's what we train against. Okay, so plt.plot, and we're plotting the loss and val loss like we did before, and accuracy and val accuracy like we did yesterday. But that may have been cut off the video. I can't remember 100%. Okay, so we're just giving title to these, plotting them. So now we're making the X test and Y test. So we're having, I'm not sure why we're doing this, why we're having 20% here, then we're making another evaluate the model. Oh, because it's already seen that model. I get it. Okay. Yeah, that makes sense. So now we're only having 200 of these 10 feature 10 feature data, and we're having Y test. It's the same function, not function, but relationship as the data set we saw up before, and loss accuracy model evaluate. Okay, then we can print it. Loss accuracy, and then this model that's been trained on the X train and Y train. Okay, so yeah, I understand this. 10 because, yeah, value activation function. Reduces complexity slightly by using sigmoid. Yep, okay. Training the model, okay. Assignment. Build and train a deep neural network for classification problem using code provided. Experiment with, okay. We could try using the MNIST dataset. Iris. Okay, I'm just going to copy this into Colab and see if it worked and see the accuracy. Okay, just running here. Oh yeah, and I've also realized that there's a green arrow as to where in the execution process the interpreter or parser is. Yeah, we can see it all the way down here. So we can see this is the costly bit where we're fitting the model, basically training the model. Okay, now completed. Let's see. Okay, at first these are very, very similar. Then we see we go a bit off track. I don't know why this is. maybe just be a bit of noise on. Well, validation loss. Validation is a smaller data set, and that's possibly why the loss is a bit higher than the training loss. But yeah, as they mirror each other quite significantly, like especially at the start. And even this bit here, you can see, so it's definitely showing some very good high relation accuracy, 98%. I mean, yeah, that's amazing when it comes to this. Okay, I'm gonna have to do this on the one of my first neural network projects, which is before this series started, which was like I had like a bunch of 5-letter words, and we have a Python dataset, data frame rather, pandas data frame, and we have first letter, second letter, and we had to do I had to do odd, which converts it to like the ASCII value, and then the computer can work from there. And I had to use like 1,000 in order for it to go well, but it only got 87% accuracy, which was not actually that good because 25 over 26 is actually greater than 25 over 26 times 100 is greater than like 87. So yeah, now we need to add a few hidden layers into it, and that will hopefully fix it. Okay, so now I'm just gonna. Okay, for the assignment, so I'll try using one of these other data sets. Okay, please just tell me the line of code that I can import the, what example did it give? The iris data set. And create the iris dataset object. Just lines, so it doesn't get off on a tangent, but can't do that. Okay, let's see. I'm curious as what the iris dataset is. Maybe a flower. In that case, we might need to do some, like, as we did with the MNIST dataset, we might need to just convert it into, like, just a standalone array, as we can't handle it. Well, it can't handle just like a 28 by 28 pixel image. So I assume it's been labeled like iris flower, but I don't know. And chatgpt is not loading. Okay, here we go. Okay. So I'm just going to create a new code sample down here. I'm also gonna copy this, and I'll have to like so I'm gonna call this instead of this X train, Y train. I'm also gonna comment this out as we're not using that bit. Oh, I suppose we could, and we can just split it. Okay. So for this iris dataset, how would I split it into 80% X train and Y train, and the 20% left? Should we do 20% into the X test and Y test? So I want to wait, what's this? Assuming you need to use one-hot encoding. I'm not too sure about the Iris dataset. Okay, train test split. Oh yeah, I've used this function before. Must be a high usage in a minute for old ChatGPT. 4.0 I realised is quite slow, but it's a better model, so more parameters. But this is super slow. Okay, this should be good. Yeah, I'm not going to print them. And let's go here now. So we're going to do X. Oops. Okay, so we're having X and Y data target. Oh, that's very simple. It's nice. Iris data. So X train, Y train, 80. Random state. Is this dropout or what? I'm just going to leave it in as ChatGPT left it in. And let's see if this works. Does it compile after that? No, it doesn't. Dense 4 is oh, how many features? How many it's still generating. Okay. I just want to also check that I don't have the Okay, 4 features. Oh, okay, it's just textual based. So we have 4 features, and we're going to go like this. Seems like it's running. Actually, oof, 30%. Goodness, what has happened here? Okay, please tell me more about the Iris dataset. At least it's higher than 25%, which would be just random. What would it be random? Probably not, no. It's probably better than that. Okay, so the Iris dataset is one of the most famous and widely used dataset in the field of machine learning and data science. Here's a more detailed overview. The dataset was first introduced by British biologist and statistician Ronald A. Fisher in his 1936 paper, The Use of Multiple Measurements in Taxonomic Problems. The dataset consists of 150 samples. There are 3 classes corresponding to different species. Okay, Setosa, Versicolor, and Virginica. Okay, 58 plus. The dataset includes the following 4 features. Okay. So we have 1, 2. So it's not. So we're not going to use that. We're going to be using softmax, aren't we? Softmax. Let's see how much this increases it by. Is this a bit slower than softmax? What? Still 30. I'm seeing the shape of the okay, what if we just absolutely go mega mode on this and just have loads and loads of neurons. But is it going to be one neuron? Is that off, like, the failing point of the program? It's not too slow. Loss. Oh my gosh. Still 30%. Well, it's got better. The curve. I just... Okay. I'll put that one. What if we have 3 neurons? Because there are 3 possible. But 3's not power of 2, so yeah, that won't be one as well. What if we have 2? But let's try increasing these old epochs and see what it has to do about it. %. Okay, let's rerun it with 150 epochs. I mean, we can see that the like gradient of the line, not gradient, but like curve of the line is becoming better and more aligned, especially at the start of it. I'm still seeing huge. Okay, might have to need to call in the old LLM in this case. Okay, maybe would ReLU be the right activation function? What if we use something? Okay, what if we use softmax for all of them? I want to see what this does. It's actually gone faster. Yeah, that's not looking great. Okay, we're going to revert. No, let's try another loss function, tan-h. So I think this one's from -1 to 1, so it's a bigger range than ReLU. So tan-h, let's have a look. It doesn't seem like adding more epochs and stuff do much to help, as we've just stopped at 30%. Okay. I mean, the line's following a bit, but it's not the amount we want. I'm gonna go back to ReLU, because that's had the nice curve. Let's ReLU. Oh, can't spell ReLU. Okay, so I'm just gonna paste this to chatgpt. I am trying to do the assignment, but I am getting only an accuracy of 30% with this code. Please provide the corrected code in order to have a better accuracy. I have changed the activation functions I've changed the amount of neurons. I haven't changed the amount of layers, but still, there wasn't a single change in accuracy, only a change in the way the loss went down, e.g. from curve to straight line. Okay, let's see what ChatGPT is going to say, and let's see this again. Still 30%. I reckon it's not a problem with all the neurons. It's going to be a problem with, like, the model. Maybe it doesn't have 4. Maybe it should have 4. What if we do 8? Okay, to achieve, there are several learning rate, but it hasn't been changing. Oh, I'm using a scalar. Okay. Oh, we didn't one-hot encode it like it told us to. So, but I'm pretty sure it told us that it was just in centimeters. 3 possible. Yeah, it was actually worse than, because there was only 3 possible answers and it was getting 30%. So that wasn't great. Let me see what it's on about. So we're getting iris dataset. We're having a standard scalar like we saw in the other lesson. It was along with like L1 regularization, L2 regularization. Really softmax. 3. Yeah, that's what I tried to do. Give me an error. 1 for each class. Maybe it's because we didn't one-hot encode it. Ah, okay. So Y2 categorical. We're passing Y. Ah, I see. So we can probably just do this. Oh. Yeah, it's not working there. Wait, what did I even change? Yeah, I changed this. So what if you do Y equals 2 categorical. I'm just going to copy paste it. And then we can get going. And then we're going to have the 3 neuron output. One-hot encoding. We've got an error. Under which namespace would this reside? So sequent. Oh, 2 categorical. Let's see. Okay. It's actually running this time. I'm gonna say, oh, that's what we like to see. Before the loss was like negative. Let's go, 90%. We have got an accuracy of 90%. Before the loss, let me have a quick look at I know. It was a different one. But, okay. One-hot encoding, that was, yeah, magnificent. I'm just going to copy paste this code in a new one now, just delete it after. Because one-hot encoding though is scikit-learn, or however it's pronounced. I heard someone pronounce it differently in a video, like scikit-learn or something. I can't remember. Right. Okay, let's see the percentage that ChatGPT has managed to get. It used a lot less. Even used 1 less layer. Okay, accuracy. 1%, 100%. Okay, wow. Well done, ChatGPT. let's see. The only thing it got different was batch size and epochs, and also the amount of layers. We had one extra layer. Yeah, we can see this is. So I don't know why we got this spike here. We're getting these random spikes. But validation accuracy, that just skyrockets, and then okay. So we can see it is going around there. It's just a bit of noise that we're getting. Yeah. Okay. So that was actually very useful, and it's just that's a really good feature. All from the Keras inbuilt into TensorFlow. Utils to categorical. So I'll make sure to use this again. Just didn't know it was actually like the string. Okay, that's good. So I think that'll be the end of today's lesson, as we've completed all the tests that ChatGPT has set out to us. Okay. Oh. Challenge. Let's see how they do. Okay. So yeah, that's the end of today's lesson. Thanks for watching, and I'll see you in the next video. Goodbye.